Hi and welcome to this video. I am Guna and my teammates are Alicia, Vera and Zuyao, and we are from the Math Interest Group. Just a quick disclaimer that there are more concepts to trigonometry than what is shown in this video, and this is just a quick recap of knowledge around some concepts and formulas. Here are the contents of this video. We will be starting with the definitions of trigonometric functions, followed by some formulas derived from and about the trigonometric relations, and then some graphs showing the relationship between a variable and its trigonometric functions. Finally, there will be a few questions around this topic that commonly appears in SMO. Sine is the opposite side over longest, aka hypotenuse side of the triangle. Cosine is adjacent side over hypotenuse side, and tangent is opposite side over adjacent side. Tangent is also the sine over the cosine. Cosecant is the reciprocal of sine, secant is the reciprocal of the cosine, and cotangent is the reciprocal of the tangent. Also, angle A in the diagram shown is x, and angle B is 90, so angle C is 90 minus x. AB over AC is equal to sine 90 minus x equals to cosine x, and sine 90 minus theta is cosine theta, and from there you can derive all six formulas on the right hand side. The radian can also be used to express the magnitude of an angle, and 180 degrees is equal to pi radians. Angles given in terms of pi without units are radians. The question may give the degrees or radians as their angle measurement, and your answer should follow the units given in the question. There are four quadrants. Quadrant 1 is when the angle is less than 90. Quadrant 2 is between 90 and 180. Question 3 is between 180 and 270, and question 4 is between 270 and 360. After 360, this goes back to 0 degrees. Angles in question 1, let's call this angle theta, have all their trigonometric functions result in a positive number, while Q2 only sine yield a positive result, Q3 tangent, and Q4 cosine. Another angle, let's call this alpha, is known as the basic angle. Basically, the trigonometric functions used on theta and give the same magnitude, but alpha is always in quarter 1. Since the negative results for theta larger than 90 degrees, relations between sine, cosine, and tangent functions of theta and alpha are shown here. In addition, in the case of negative angles that rotate clockwise around the diagram, sine and tangent are always opposite to the sine and tangent of the same positive angle, which rotates counterclockwise around the diagram. However, cosine always are the same. The reason is that Q1 and Q4 sine and tangent give opposite values, and likewise for Q2 and Q3. However, for cosine Q1 is equal to Q4 and Q2 is equal to Q3. This leads to the formula shown on the bottom right corner. Here are some useful formulas. The second and third one can be derived from the first. This works for any and all angles. There's also the compound angle formula, which is the expression of trigonometric functions of the sum of two angles into trigonometric functions of only one angle. The double angle formula, underlined on the right hand side, derived from this goes as follows. This is a special case that holds if and only if angle A is equal to angle B. And this is what you probably came into this video for and will probably do so many more times in the future. A quick refresher to the sum to product and product to sum formulas derived from the compound angle formula. They are also equivalent to each other, just reversed. Now we move on to another formula, also known as the R formula. R formula basically helps you sum up a sine function and a cosine function into one trigonometric function, especially helpful in calculus to draw the graphs to determine the minimum and maximum values that this function can hold. Here are the four R formulas. Take note that the last three are just the more complicated version of the first one, and these four formulas apply for all the angle cases while keeping the variables as positive values. The capital letter R is equal to the square root of a square plus b squared, and alpha is the inverse tangent of b over a. To find inverse tangent value, simply press shift and then tan on your scientific calculator. Here's the process that proves that the R formula holds true. An example question will be provided later on about this if you don't understand by replacing some of the variables with numbers. For the first step, only the proof for I is shown. But here at the bottom is what to convert the initial expression into for I, and IV. And then the steps follow similarly. Here is the sine graph. This can be understood by imagining P moving around the circumference of a circle. As P moves around this circle, the value of psi function repeats itself every 360 degrees. This length is known as the period. Likewise, cosine and tangent are also periodic functions. Sine curve oscillated around the x-axis, and the distance between from the maximum/minimum point from the x-axis is also known as the amplitude. The general equation is shown in the italic text, where A, B, H, and K can affect the shape of the sine curve, better known as the wave. A is the amplitude, B is the period, H is the translation parallel to the x-axis, and K is the translation parallel to the y-axis. The period is 360 over the magnitude of B. So these are the graphs. So red is sine, blue is cosine, and green is tangent. So this is example question 1. And this is the solution. So since 2 cosine x sine x is equal to sine 2x, cosine 20 theta 20 degrees sine 20 degrees is equal to sine 40 degrees divided by 2. Similarly, sine 40 degrees cosine 40 degrees is equal to sine 80 degrees divided by 2, and sine 80 degrees cosine 80 degrees is equal to sine 160 degrees divided by 2, and sine 20 degrees cosine 20 degrees cosine 40 degrees 8 cosine 80 degrees is equal to sine 160 degrees divided by 8. Since sine 160 degrees is equal to sine 20 degrees cosine 20 degrees cosine 40 degrees cosine 80 degrees is equal to sine 160 degrees divided by 8 sine 20 degrees, which is equal to 1 over 8. So example question 2. The solution is, let 3 cosine theta plus 4 sine theta is equal to 3 cosine theta minus alpha. By combine angle formula, 3r cosine theta minus alpha is equal to r cosine alpha cosine theta plus r sine alpha sine theta. By comparing coefficients, r cosine alpha is 3, r sine alpha is 4, hence r square sine square alpha plus cosine square alpha is equal to 3 square plus 4 square equals to 25. Hence r equals 5. R sine A over r cosine A is equal to tangent A, which is equal to 4 over 3. So alpha is tangent arc tangent 4 over 3. 3 cosine theta plus 4 sine theta is equal to 5 cosine theta minus tangent to the arc tangent 4 over 3. Since negative 1 is for since cosine theta minus tangent arc tangent 4 over 3 is greater than or equal to negative 1 and smaller than or equal to 1, and so negative 5, so 5 cosine theta minus tangent arc tangent 4 over 3 is greater than or equal to negative 5, uh, and greater than and smaller than or equal to 5. Minimum value is negative 5 and maximum value is 5. Minimum value is achieved when cosine theta minus arc tangent 4 over 3 is equal to negative 1, theta equal pi plus tangent to the arc tangent 4 over 3. Maximum value is achieved when cosine theta minus arc tangent 4 over 3 is equal to 1. So theta is equal to arc tangent 4 over 3. So example question 3. Solution is 2 sine 2x cosine 4x is equal to sine 6x plus sine negative 2x, which is equal to sine 6x minus sine 2x. 2 cosine 6x sine 8x is equal to sine 14x minus sine negative 2x, which is equal to sine 14x plus sine 2x. Hence 4 sine 2x cosine 4x cosine 6x sine 8x is equal to sine 6x minus sine 2x sine 4 times sine 14x plus sine 2x. So the references, most pictures were taken from the NVS 5 Year 3 Math Notes, and a graph was created with Desmos. Thank you.